So, again, intro to probability and the fundamental counting principle. The intro to probability, I think, is going to be something, again, you guys probably already know how to do, but I want to make sure we're all on the same page. One really quick thing before we start. If you want to write this down, you can. You don't necessarily have to. But your answers, I either want to be in a reduced fraction, a decimal, round to 2 decimal places, or a percentage. So your answers literally not only do they have to exactly match what your neighbor's doing, but there are times that I do a percentage, there are times that I do a decimal, there are times that I do a fraction. It does not matter what you decide. I would do whatever's easiest. For me personally, what I usually do is I usually leave it as a fraction, unless if you put a fraction that can be reduced, that's like 72. If you reduced and you have to use your calculator, then I just put it as a decimal. Because if I'm going to use my calculator to reduce a fraction, I usually put it as a decimal. Depends. Percentages are easier to read. If you see something, again, that's 54 over 516, that doesn't tell you a lot. But if you see what a percentage is, that gives you a little bit more information. So again, it's all up to you. For answer keys, I try to give all the formats. I don't remember in this first one if I gave the decimal answer, but either way. So there are different ways to define probability, or to say, kind of give you, I guess, a quote unquote formula for it. Probability is how likely something is to happen. And again, you guys have heard this all the time where you say, what's the probability of, when I take a dice and I roll it, what's the probability at a 3? That's something you guys have all probably dealt with before. So I give this formula, and I've seen a couple different ways it's written. This is the number of success over the total number of outcomes. What I usually say for this, the success, I usually say, to make it easier, can't really read that probably, it's what you want over the total. And I think that's a very simplistic way of looking at it. I think that helps a little bit. The same thing, number of success is what you want. But if I say, what's the probability of rolling a dice and getting a 3, what do you want? You want a 3. So how many 3s are there? There's 1. What's the total? A dice have 6 sides. Be 1 over 6, which is what we'll get into as well. Also, for those of you who are Dungeons and Dragons fans, or those of you who like to be smart Alec, for no better school appropriate term. If I say it's a dice, just assume it's a standard 6-sided dice. I've worked with people that every time they say dice, they put standard number of cube, because they're like, oh, there's more dice out there. And so if you want to be like that, that's fine. You'll probably get it wrong. That's not my problem. Okay, so these are very basic probability questions. What's the probability of flipping a coin and it lands on heads? Well, what do you want? You want it to be heads. How many heads are there? 1. You have 1 head, 1 tail. Total outcomes do you have? It's either heads or tails. You have 2. It's just 1 out of 2. And again, for me, because that's the easiest, I don't have to do any extra work. If you want to, you can put 0.5 or 0.50, or you can put 50%. I literally couldn't care less. Whichever way you want to do it is fine. What's the probability of rolling 4 on a dice? I will say easy, and we talk like it's a no-brainer, but I have had people that miss this because they read too quickly, and they say, what do you want? Well, you want a 4. How many sides are there total? 6. Well, that's wrong. You want a 4, but how many 4s are there? 4. Fall for that. So there's only 1 4 out of the 6 sides total. Also, in case you're wondering, die is a singular form of dice. Dice is when there's 2 or more. I also probably messed that up a lot because, frankly, I don't care. If I cared, I'd be an English teacher. And a nerd. Haha. Take that, English teachers. We should bully them online. So 1 over 6, again, I leave it like that because I need a calculator to find the decimal. But as a decimal, that's 0.16666. So that's 0.17. Please round to 2 decimal places. And then that's 17%. And the reason I tell you to round to 2 decimal places, that's usually what I do anyways, but also makes your percent have a decimal, which it's possible to have like 17%. We don't need to go into that much detail. There's a spinner has numbers 1 through 15. This one should make a couple of these different. Okay. 1 through 15, what's the probability of spinning an 8? You have 1 8, you have 15 total, so it's 1 out of 15. So again, in your calculator, that is 7%. I will bring up 0.07 is 7%, not 7. I had people before that think that's 70%. And flashcards, each one has a letter on it. Just in case you're wondering, there are 26 letters in our alphabet. What's the probability of picking 0? It is 1. We're not going to go into super detail on these. Like I've done this before, where I do go into more this probability, and I literally give a printout that says there are 52 cards in the deck. There are 26 letters in the alphabet. There are, however, like, and some of that stuff people don't actually know. Be 0.04, which is 4%. Okay, now these next ones are a little bit more involved for a couple different reasons. The other ones hopefully are pretty straightforward, but again, I like to kind of start with that base. If I roll a die, what's the probability I roll an even number? Now, actually, I'll first, and then I'll talk to you about the catch of this one. How many even numbers are there? Well, I have 2, 4, and 6. Don't be scared to write them out. 3 that are even out of the 6 total. Make sure, remember, again, it's the total on the bottom. Don't put, there's 3 evens and 3 odds, so it's 3 over 3. 1/2, which is 0.5 or 50%. I don't care which way you put it. Do not leave it as 3 over 6, please. That they say, if it's an even number, half the numbers are even in this world, half the numbers are odd. So if I'm even doing any work, they put 50% move on. You're absolutely correct for this example. For some other examples, it does get a little bit different. I'll explain why once we get there. So this one, I actually put 3 questions in one. We have a spinner that has numbers 1 through 15. What's the probability of a multiple of 3? What's the probability of an even? What's the probability of an odd? Now, look at this, or you help yourself process this. I've done it a lot if I literally just number 1 through 15. So 1, 2, 3, 6, 7, 8, 9, 10, 14, 15. You do not have to do this if you don't want to. But it is a good way to stay organized. As I've said before, that's the hardest part for some people. So what's the probability of spinning a multiple? Multiples of 3 are 3 times 1 is 3, 3 times 2 is 6, 3 times 5, 3 times 4 is 12, 3 times 5 is 15. So I underline 1, 2, 3, 4, 5. So there are 5 multiples of 3 out of the 15 total. When you reduce that down, you divide both of them by 5, you get 1 over. You can, again, obviously make it a decimal, make it a percent. I'm going to leave it as 1/3 because I want to save some room since there's questions in this one problem. So here's where it gets tricky a little bit. What's the probability of spinning? This is where a lot of people miss this, and a lot of people think this is super easy, and this is one of the ones we miss, because they say, well, it's 50%, because half of them are odd, half of them are even. My question is, are half of them even? Are half of them odd? Let's count the even. 1, 2, 3, 4, 5, 6. I counted 7 evens, right? 6, 8, 10, 12, 14. 7 evens. Well, if there's 7 evens, how many are in there total? 15? That is not 50%. For me, I always double check. I never just assume that evens are going to be half of them and odds are going to be the other half. That doesn't reduce, so you can leave it like that. Again, make it a decimal, make it a percent, that's fine. So on the other hand, how many of them are going to be odd? Well, we have 1, 3, 5, 7, 9, 11, 13, 15. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them odd. So how can that be that when you talk about evens and odds, it's every other one is even, every other one is odd? So how can it not be a 50-50%? Well, the reason is because this one starts with an odd number, and then it ends with an odd number. So there's one extra odd number because it starts with an odd, and ends with an odd. And end with an even, there'd be one. Again, every other one is even, every other one is odd, but if you start with even, that's the last one at the end. In order for it to be 50-50, if you actually want to know the code, it's got to either start, whatever it starts with, has to end with the opposite. If it starts with an even, it's got to end with an odd. If it starts with an odd, it's got to end with an even. And for whatever it's worth, 0 is an even number. So again, for me, I never take that for granted. Obviously, it gets a little bit harder if I said I numbered them like 1 through 111, where you can't just make that list. But I'm not going to give you anything outlandish like that, so you can always take the time to write it out and circle and double check stuff. Cards on each one have what's the probability of picking a vowel. Now, for whatever it's worth, in this chapter, if I ever talk about a vowel, we're talking about the A-E-I-O-U, the sometimes Y rubbish. That's an English thing that bothers me because it's not a rule. I like math because if something is a vowel, it's always going to be a vowel. And then English is like, well, but sometimes why? It's like, get out of here, English. That's like, I knock their books out of their hands in the hallway very frequently. It hates it. Do that. Again, there are letters. Each has so there's 26 letters total. There are 5 vowels. A-E-I-O-U. Again, in this class, we're not counting Y. That doesn't cut it. Sometimes it's not all. So 5 over 26. Again, if you're not sure, if you look at that one for me, I know just by looking at it, I know it can't be reduced. I've also had roughly between 13 and 15 years of Algebra 2, so yes, I'm very good at that. If you look at that and you're not sure, I'd put it as a decimal, just because, again, in my calculator, it's easy enough to do that. I guess your calculator, you could put in a fraction, so maybe that's easier. Bottom line, if you're not sure, I'll make sure you double check. That's kind of the punchline. It goes to 0.19, which is 19%. And the last one, I have a class of 23 students, 10 of them boys. If I pick a student at random, what's the probability that it is a girl? Now, one of the things you have to realize, you know this without even thinking about it, if there are 10 boys, if there are 23 people total, that means there are 13 girls. So what's the probability it's a girl? Some people mess this up because, again, they out of 23, that's boys. There's 10 boys, there's 13 girls. So 13 over the total of 23. Again, that can't be reduced, but if you want to put in your calculator anyways to see the decimal, that's 0.57, which is 57%. Are there any questions on those? Okay. These are all ones that you're talking about rolling 2 dice. So there are, I don't know how many people give on a test or quiz, but a lot of times when you talk about probability, it comes to rolling 2 dice. Imagine it's probably whatever that game in Vegas you always see where they take the 2 dice and they roll it, and then savings or something doesn't ever go well. But you roll 2 dice, so what's the probability that you roll a 6? What's the probability to roll a 7? And these problems are more difficult because if you roll 1 dice, there's only 1, 1, or 1, 2, or 1, 3, or 1, 4. When you roll 2 dice, there's several different ways you can come up with 6. You could roll a 2 and a 4. You could roll a 1 and a 5. So that's what makes this one a little bit more involved. So before we do anything, how many total numbers of outcomes are there when you roll 2 dice? We will talk about this a little bit later, but there's a total of 36 outcomes. If you want to list them all out, you can. It wouldn't take that long. There's only 36. You could get a 1 and 1. You could get a 1 and a 2. So list them all out. 1 and a 2, 1 and a 3. I will tell you, in this class, we count it differently. A 1 and a 3 is different than a 3 and 1. Those are 2 different outcomes. I know it ends up with a 4, but when it deals with probability, that does something different. When we do these problems, it helps to, rather than thinking about taking 2 dice and rolling both of them at the same time, it almost helps to think of rolling 1 at a time. You roll your first one, and then you roll your second one. So to get a 4, you can roll a 1, 3, or you can roll a 3. Okay, so there are 36 total outcomes. 2, 1, 3, so on and so forth. 2, 1, 3, 1, 3. Anyway, all those outcomes. So if I roll 2 dice, what's the probability that I get a sum of 4? Now there's ways to do this, and it is all up to you. I've had students do it every other way. I've had some students that all the complete options, all 36 of them, and then they go through and count how many of them add up to be 4. It really wouldn't take that long. The ones that add up to be 4, there is a little pattern. You'll be able to see that pretty quickly. The way I like to do it is I would rather just list out 36 possibilities. What are all that add up to be 4? That's a possibility. 4, I can do 1 and 3. 2, is there 2? Yeah, I can roll a 2 and a 2. 3, I can roll a 3 and a 1. You can't do 4 because there's no 4. You can't roll 0 on the next dice, so that doesn't work. So outcomes where you can roll a 4. Now again, one of the things you have to be aware of, and I know it's a little confusing, when it's 2 and 2, you don't have to write that in the opposite order because they're both 2. It seems confusing. That counts as 1. So from here down, 3 out of 36. Again, you can divide both by 3. That ends up being 1 out of 12, I believe. Yes, want to check my math just in case. That's the same thing as 0.08, which is the same thing as 8%. Next one, if I roll 2 dice, what's the probability that they sum, they add up to be 6? Well, again, I know that there's going to be 36 possibilities. Ones that add up to be 6, again, I would start with 1, so I have 1 and 5. 2 and 4 work. 3, again, you don't count 3, and you go on to 4. 2, and 1, and then again, we're done, because we can't go to 6, because it's not 6 and 0. So we have 1, 2, 3, 4, 5. There are 5 out of 36. We can't reduce that down. Again, if you want to put a decimal, you can. You do not have to on this one, on any of these. I roll a dice. What's the probability that they add up to be 2? You have 1 and 1. That's it. So there's only one option out of the 36 total. What's that on there? If you roll 2 dice, what's the probability they add up to be 1? Does anybody know this one off the top of their head? There's none of them. You can't roll 2 dice and get 1. That doesn't make sense. So I put this on here on purpose. I don't try to trick you, but it's possible to have a 0. You cannot roll just to 1. What's the possibility you roll where they add up to be 115? 0. They don't ever add up to be 115.
Now, on the flip side of this, you could say there also are probabilities where it's 100%. Like if I take one dice and I roll it, what's the probability that I roll a number that's less than 10? Well, it's 100%. They're all less than 10. Okay. So we won't get back into probability now until Wednesday. Really good stuff. We're going to get into the fundamental counting principle. I personally think this is fun. That's fine. That's very loose. I didn't do this weekend, like for fun. I didn't like crunch. But I think it's interesting. I don't think it's that hard. And again, this is one of those that maybe you guys haven't thought of, but I certainly have, and I can give you some examples once we get started. So I was definition of this. Every definition I found, like it's just hard to define this that makes any sense. So it's easier to use an example as well. So this is kind of half and half. It's half of a definition, half of an example. Again, all the definition I found, they use like letters. It's confusing. Certainly it's more confusing than what it actually is. So if an event A has 4 different outcomes and event B has 7 outcomes, so we have 2 things that are happening. One, there are 4 different outcomes that can happen. One, there's 7 different outcomes. Then the total number of outcomes of event A and then event B happening is 28 because you take 4 times 7. And that's kind of not really definition because they use numbers. But that's what you do. If you have 2 things that are happening, you take the number of outcomes for both and you multiply those together. When you roll 2 dice, we're not talking about probability anymore. So that's, and again, I apologize. I put them both in the same lesson, but this is kind of the best way to put everything in. When you roll 2 dice, we said there are 36 total outcomes. And I said you could actually list all of them. But what they're saying is if the first dice has 6 outcomes and the second dice has 6 outcomes, then the total number of outcomes when you roll both of them is 36. That's the math we're doing. So the way that they do this a lot, or this is a lot of today are going to be very typical Algebra 2 questions. As far as like if you look at any algebra book that's been made for 20 years, Algebra 2 book that's made in the next 10 years, they will have examples that look like this. So there's a restaurant that serves a lunch special that has a sandwich, a side, and a dessert. For example, you want to give her this. You pick one of each. How many different meals can you have? So how many times can I go to this restaurant before I have to have a meal that's the exact same as another day that I went? Now, again, keep in mind, a hamburger, potatoes, and apple crisp, that is a complete different meal than if you have hamburger, potatoes, and a cookie. It seems like it's similar, but for our math purposes, we need exactly the same meal. Everything's got to be the same. So the way I do this is I put my 3 options. I have my sandwich, I have my side, I have my dessert. I have to label those. I think it's very nice to label them. With one like this, most of you guys don't have to. Most of you guys won't. That's great. Later on, though, we'll have with license plates that it's very nice to make sure you map. See some of those in a second. So, how many options are sandwiches? 1, 2, 3, 4. Options of those. How about sides? We have 1, 2, 3 different sides to choose from. 1, 2, 3, 4. So, how many outcomes total? Well, we'd have 4 times 3 times 4. Put that in your calculator. I would not recommend doing it mentally. That is 48 different meals. Now, again, you could do this on your own without doing that by saying, and it would help to eventually get a hamburger, potatoes, apple crisp option. Hamburger, potatoes, cookies a second. Hamburger, potato flan is the third. Hamburger, potato, hamburgers, beans, apple crisp. That's a fifth. Hamburger, beans, cookie. That's a sixth. You could actually list them out like that. It would just take way longer. So again, there's 4 sandwiches, 3 sides, 4 desserts. That's the fundamental counting principle. And again, this is not probability. I'm not saying that what's the probability you pick a sandwich. That's not it at all.
We want to know how many different outcomes are possible. So this is another one that's very typical. In 1966, one type of Maryland license plate has 2 letters followed by 4 digits. How many types of license plate were possible? And this one, maybe I was just a mathy kid, but it's like how many, especially now that everybody has a cell phone. Back in the day, if you had a family of 10, you still had this one landline that's connected to the wall. Nobody ever called. Now everyone has a cell phone. So how many different options are there for cell phone numbers? Do you have the same cell phone number as somebody that's in California just because they ran out of options? So it's the same type of idea. We're just talking about license plates. Again, for me, it says we have 2 letters. I label those. Each one's a letter. Digits, 1, 2, 3, 4. Either D or a number sign. Tag and not a number sign, I suggest putting a D for digits. And again, that's why I like to label these. It does not make an important distinction. Everything can be repeated in this one so far. So whatever letter you have at the beginning, the second letter can be the same letter. You could have AA or AB. Sometimes they throw a wrench into these problems and say repeats, you can't have repeats. And we'll, I imagine, talk about that. Must be tomorrow. So letters, there's 26 letters. Now here's the other thing, and by after this, hopefully you'll remember this forever. How many options are there for digits? Now remember, when we're talking about digits, we're talking about single digits, single numbers. And a lot of people say 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 2 digits. However, how many digits are there? It's not 9, it is 10, and it's because a lot of people forget about the digit 0. Which makes sense because when you get to 10, you need a 1 and a 0, which there in fact states 0 is a digit. So single digits, 0 is a single digit, so 0 to 9, there are 10 different options for those. And again, you can repeat, so you have 10 for all of those. Now, fundamental counting principle, just like we did, multiply all those together. So this one's obviously going to get a pretty big number. That ends up giving you 6760000. You do not have to use commas. Sometimes it makes it so you can actually read without crossing your eyes. So 6,760,000. And obviously, it probably will get you a pretty big answer because we're talking about how many license plates are total in Maryland. How many different ways can you choose 3 digits and 4 letters? So 3 digits, 1, 2, 3, and then 4 letters, 1, 2, 3, 4. Again, 3 digits, 4 letters. Again, you don't have to label them, but I think it is very handy to organize like that. However, repeats don't exist. So again, this is one of those that some students, if I just told you to do this on your own, some would be fine because some of you guys are smarter than I am. Some of you guys will struggle with this, but it's not that bad. How many options do we have for the first digit? We have 10. Here's where it gets a little bit tricky, but not really that bad. Once you think about it, totally makes sense. How many choices do we have for the second digit? Well, now we only have 9 choices. Well, number 1 digit, you can't have number 1 for your second digit. So whatever digit you have at the beginning, you have that digit again. Options. I have 9 options because we already used one of our options. Which then, the next one, there are only 8 options. 10. Now the next one, we repeat that first one, so now we have 9. Well, now we can repeat either of those first 2, so now we only have 8 options left because we already used 2. Same thing with the letters. Our first letter, we have 26 options. The next one, we only have 25 options because, again, we already picked one of the letters. We don't know what the letter is. It doesn't matter. We only have 25 options left because one of the options we already used up. Next one, we only have 24 options left because we have 2 options already used up. And the last one is 23 options because we already used 3 options for those previous ones.
So once you get here, you multiply all those straight across. 10 times 9 times 8 times 26 times 25 times 24 times 23. Gives you 258336000. Again, you do not have to add the commas in there.
A little bit easier to like make sure you have the right.
Again, don't make that harder than it is. If you do not repeat any number, every single time, every number, one less option because we've been using those. Ways can 5 people sit in 5 chairs? We have 5 chairs, and this is where it gets a little interesting. 1, 2, 3, 4, 5. The biggest key is you can't sit 2 chairs. This is where somebody in here is like, well, what if you move 2 chairs really close together, and then you sat in both of them, and if that's you, you can go to the office. You have detention now. No, I get that this is one of those things that if you're one of those kids that wants to find a loophole, I'm sure there is one. And honestly, if you want to go with that, by all means, you can put that on the test. I'm going to count you wrong. I'm going to live my life. So obviously, we're going to say you can only sit in 1 chair at a time. So in that first chair, how many options do we have? How many students do we have to pick from? 5. Paul, he sits in that first chair. Now how many students do we have to pick in the second chair? Well, Paul's already in that first chair, so we don't have 5 options anymore. All we have is 4 options. In the next chair, well, again, we have Paul and we have Sandra that sat in those first 2. So now we only have 3 options left for that next desk. So the next one, we have Paul, Sandra, and Simon. We only have how many options left? We only have 2 people left standing there. And Dorothy, how many options do we have in the first chair? There's only 1 person left. There's 1 person standing there. Last one, there's only 1 empty chair, so that person sits in that empty chair. I didn't say anything about repeats for this one, but it makes sense because, again, if you think about it logically, you can't sit in 2 places at once. So, 5 times 4 times 3 times 2 times 1 is 120. What I just found, because sometimes once we get into this math, we forget. I'm trying to find how many ways can I sit those 5 people. So how many ways can I take 5 people and sit them in a row where we have, what was it, like Paul, Sandra, Simon, Dorothy, and Tim? And then they all stand up and I sit them down again. And then they all stand up and I can sit them down again. How many different ways can I set them up before I finally get the same order that happened before? How many different ways can I do it before I have to repeat an exact order from before? You can do 120 times. So after 120 set them down, no matter how they sat down, it would be a repeat from one they already did. Can 5 people sit in 3 different chairs? So now we only have 3 chairs. Don't make this harder than it is. The first chair we have 5 options. The second chair we have 4. The third chair we have 3. There are not 2 other chairs left. Those last 2 people are either standing or sitting on the floor. I don't know. So 5 times 4 times 3 is 60. And again, we're asking how many different ways can we sit those 5 people in those 3 chairs? You sit 3 people, and then those 3 people stand up. You take the 2 people that haven't sat down yet, and you put them down with one other person that was a repeat. And then you get those to stand up, you sit them in a different order. I mean, you could have, without even using your whole 5 people, you could have Sally, Bill, and Tim, and then you have Tim, Bill, and Sally, and then Sally, Tim, Bill. People, you can mix it up several times. And you also have the 2 extra people. That's the math to do it. I don't want to confuse you, but I also, some students get really about probability and fundamental counting principle in one. So I just want to make sure you understand that we're finding how many options we have, how many different outcomes. Last but not least, I know that this lesson, there's a lot I threw in here.
what I tried to do is I tried to figure out where I could put everything. And I thought at least this first lesson,
it's not too mentally taxing. The thing we're going to talk about is called a factorial. Factorial is when you number by all the previous numbers. So if you have 5 factorial, which by the way is represented by an exclamation point.
And I'll do, if it's 5 exclamation point, that is 5 times 4 times 3 times 2 times 4. That's what factorial is.
On your calculator,
It kind of depends on what calculator you have. If you have any button that says like PRB, that stands for probability. Sometimes you have to hit that probability button first. The button somewhere is an option there. So that does happen sometimes. Calculator, you have to hit like 4 buttons to get over there. So if you're using a calculator,
let me know. If you can't find that factorial button anywhere, please let me know because this is going to help your life a lot for these next couple. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. You have to show your work for this. I'm assuming you guys can do 6 factorial either in your calculator
or actually multiplying it out with either using the factorial in the button or multiplying with your calculator. That is 720. 6 factorial, 6 times 5.
3 times 2 times 1, 6 factorial.
4 factorial is 4 times 3 times 2 times 1.
This one you can probably do in your head. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. 12 factorial is a little bit more difficult. Oh, that's a really big number. 479001600. Now here's one key that you have to learn with this that is a little bit confusing. 0 factorial is always going to be 1.
If you need to type that in your calculator, honestly for me, I always tell students that my goal is that you at least know that 0 factorial is weird, and so you at least try to type in your calculator to double check. 0 factorial is just 1.
So every time you have 0 factorial, a lot of people think it's 0. I get it. But it's almost like saying how many different ways 0 people line up with the board. There's one way. Nobody goes up there. So this is the problem we just did. How many different ways can 5 people sit in 5 chairs? Well, we just talked about that on number 17 up here.
Is I know it's 5 factorial. That's all the work. 5 factorial and then put the answer. I'm okay with
that. Make sure you actually write down 5 factorial though. That ends up being what we said before, 120 different options.
We're talking about permutations and combinations. Talk about that factorial a lot, as well as some other things that your calculator does.
Sorry that it's 6 so long, but again, it's pieces of information. I'm hoping all the other lessons are short. They might be a little bit more difficult, but hopefully.
Any questions, let me know. Again, those of you need to take the NWA, try to get you on that tomorrow.